Hey everyone, my name is Quinn Chen and I'm a Senior Solutions Architect at AWS. Currently, I'm based out of Seattle and previously I was in Australia. I've been here for about 6 months. Love to talk to you today about Amazon Connect and the new offerings that we have.
Hi, everybody. My name is Mike Nolan. I am a Senior Solutions Architect here at AWS as well, specializing in Amazon Connect. And today, Kuhn and I have the opportunity to go over some of the new feature functionality that we're releasing with Amazon Connect. So excited to be with you today.
Amazon Connect is an easy-to-use omni-channel cloud contact center, and we enable businesses to deliver fast, secure, and high-quality personalized customer service. Agents on our platform have efficient tools and one UI to deliver productive customer conversations to improve the customer satisfactions. And managers have a machine learning powered contact center to understand customer sentiment and can set up quickly and make changes in minutes and not months. Today, we wanted to give a quick overview of Amazon Connect Chat, want to make an introduction to the new message streaming APIs that we're releasing. Mike then will talk through the solution architecture of the framework we've built to enable SMS and other digital channels. I then will give a demo of the functionality. Then Mike will do a code walkthrough, and finally we'll get hands-on and deploy this solution step by step. So Amazon Connect Chat is one of the capabilities inside Amazon Connect. You're able to build once and create a consistent customer experience for both your voice and chat channels. You're able to leverage the same authentication mechanisms, the same data dips, the same AI functionality inside Amazon Connect to provide that self-service, no-code integrations. You're able to uh, really enhance your customer experience by providing them access to the channels that's convenient to them, enable them to reach out and ask for help when they need to. You're able to cross-train your agents on multiple different platforms. And finally, and the most important thing is, we have an open platform where data can be accessed through different third-party integrations, as well as giving you the ability to draw and get insight out of the customer conversations that you have to further improve that customer experience. And like everything in the cloud, you pay for what you use. With Amazon Connect, there are no licenses, overhead charges that you have to pay. You simply pay for what you use. Some capabilities for Amazon Connect Chat include a out-of-the-box chat widget that you can deploy easily by embedding a few lines of code in your existing application. You can enable interactive messaging with automated self-service using our ML AI function chatbot. You're able to attach attachments to enhance your agent experience. And finally, you're able to, out of the box, have an integration with Apple Business Chat to provide a service for your Apple iOS users. We currently support Apple Business Chat out of the box. And now with the introduction of these message streaming APIs, you are now able to build integrations with SMS and third-party message services by subscribing to a real-time stream of chat messages. In addition to the Amazon Connect Chat WebSocket connection, this API exposes a webhook endpoint to allow the subscription of these messages so you can send messages back and forth between these third-party platforms. You're able to achieve new use cases such as integration with SMS digital channels that we spoke about, but also things like push notifications. If an agent replies to a customer, you're able to send a push notification to the device of the customer's device. But also you can do real-time analytics on these chat messages as they are sent through via a live real-time stream and perform analytics on these using our AI services. A few things to note include this does not incur additional charges on the Amazon Connect chat service. It is still the per chat message pricing, although there could be some additional cost related with the subscription simple notification service that is involved in the architecture that Mike will go through in a bit. So a brief overview of how the API works is once you start the chat contact, you can subscribe the chat messages to a streaming endpoint using the simple notification service or SNS endpoint. Once the subscription is set up, the Amazon Connect chat service will start streaming all the chat messages through this SNS endpoint where you can subscribe business logic to the stream in order to process these messages. To get started, create an SNS topic and add resource-based policy to the topic to enable Amazon Connect to publish messages to this topic. Then initiate the chat using the Start Chat Contact API. Then use the Start Contact Streaming API to register the SNS topic to the chat so the Connect service knows which topic to publish messages to. Finally, use the Create Participant Connection API to confirm the connection. Now Mike is going to give an walkthrough of the architecture.
Thanks, Kuhn. So here we're looking at the AWS architecture for the framework that we're building around this feature functionality set to enable SMS integration as well as other native channels, digitally native channels here. So if we take a look at this architecture and we kind of draw a line down the middle is how we can kind of split this out between our inbound leg and our outbound leg. So that's represented here by these white circles for our inbound leg, so the customer coming into Amazon Connect, and then the yellow circles represents the outbound flow, so the message is coming from Amazon Connect back out to the customer. If we start in the upper left-hand corner here with the customer reaching out to engage with one of our agents or one of our IVR experiences, the customer is going to come in, and for this we'll say text. So the customer is going to text in, and it's going to reach out to one of our endpoints, so Amazon Pinpoint. Amazon Pinpoint is our flexible and scalable outbound and inbound marketing communication service that also enables us to do two-way SMS communications. Step one here is our entry point for text messages. Like I said, that's going to go straight to Amazon Pinpoint. But like Kuhn alluded to previously, we also built this framework to be extensible to digital channels. Those digital channels use APIs to communicate back and forth with their messaging platforms. So in order to integrate with those digital channels, we've introduced Amazon API Gateway to be the endpoint in the front end for those digital channels. Step two, so after the message has landed onto one of the two endpoint services, then step two is to facilitate that message to AWS Lambda. So for Pinpoint, the way that two-way SMS works within Pinpoint is that you subscribe an SNS topic to Pinpoint, to a specific phone number. And then when an inbound message comes into Pinpoint, it publishes that message to Amazon SNS. And then finally, we reach AWS Lambda, who is a subscriber to our SNS topic. Meanwhile, down below for our digital channels, Amazon API Gateway actually has native integration straight into Lambda function, so there's no need for that SNS service in between. Once that message has been received within AWS Lambda, so then we call Amazon Connect's API for the Start Contact API, and what we get back from that is a contact ID. Now within this Lambda function, we have three pieces of information that we need to facilitate a chat. We have the contact ID of the conversation within Amazon Connect, and then we have two pieces of information from our channels. The first piece of information is what channel that is. So in these two instances for Amazon Pinpoint, we're assuming that anything coming from Pinpoint is going to be an SMS message. And then for our digitally native channels, coming from our Amazon API Gateway, each of those are actually going to have an individual web path that you can send messages to. So from that path, we're able to determine what channel this message has derived from. And then the final piece of information we have in this Lambda function is going to be a unique identifier for the initiating channel. So for SMS, that's pretty simple. That's going to be the customer's phone number, right? So that's a unique identifier tied to your phone. And then for digital channels, they will also pass an ID, a unique identifier for that user as well. What we refer to each of these is going to be called a vendor ID. So whether that's the phone number or whether that's the opaque ID that we're receiving from one of our social channels or digital channels. So those are the three pieces of information we have with that Lambda function. So what we do with those three pieces of information then is we save them into our DynamoDB table. And we say, and we'll come back to exactly why that's used and how that's used here shortly. And then once we have all of that information in our DynamoDB table, we have everything that we need to facilitate messages into Amazon Connect. So for our first message, we established a chat contact. We started our streaming service to an SNS topic, and we've saved our connection metadata into our DynamoDB table, along with our vendor ID, our channel, and our contact ID. Now, when subsequent messages come in from the same channel, we use and get to this Lambda, we do a database lookup to pull up using the vendor ID and the channel to pull up that contact ID that Amazon Connect is aware of. And we use that contact ID to send the message into Amazon Connect and to be routed to the respective chat. On the outbound side of things, so in step 4, we subscribed to the chat. We subscribed an SNS topic to the chat. So now, as part of step 1 in yellow down here, the outbound flow, when an agent or an IVR has an outbound message to relay to the agent, that is going to be published to the SNS topic that we subscribed or that we set up as part of the step 4 in the inbound. And then from that SNS topic, we actually have another Lambda function here. This is our outbound Lambda that is a subscriber to SNS. So when the message from Amazon Connect gets to our AWS Lambda function here, the only piece of information that we have is the contact ID, along with the message and the message metadata. So in order to figure out who the appropriate recipient is on the integrations channel side, we need to go back to our Dynamo database table and pull back that channel and that the channel and the vendor ID from our database, so we know to tell Pinpoint, or we know to tell an API, an API on one of the digital channels, who they're sending it to on their side. So as part of this Lambda function, we're using Pinpoint to say, hey, I need you to send this message to this phone number. Or for our digital channels, we're passing it within the payload and we're saying, hey, here's the message, here's the ID that you gave me in step 1 over here. Please send this message to the appropriate recipient. And that's a high-level view of the architecture of the solution. Coming up next, Koen's going to talk to us about, I think actually going to walk us through a demo of this architecture. Koen?
Thanks, Mike. For today's demo, we will demonstrate the SMS channel using Amazon Pinpoint. But just like Mike said, the framework supports the ability to add in other digital channels. Out of the box in our GitHub repository, we're going to have an example with reference architecture on how to set this up for Facebook Messenger and instructions on how to get that enabled. And based on the reference architecture, you're able to quickly develop your own support for other channels such as Twitter, Slack, and WhatsApp. So for the demo today, we have a car insurance company called Any Company. And as a customer, I got into an accident the other day, and I want to file a claim. So I'm going to text the company to figure out what my next steps are. So I can start off the conversation by sending any message, and this will reach the contact flow for the Amazon Connect instance. The contact flow is able to use customer profiles, Amazon Connect custom profiles, one of our other capabilities, to look up my profile based on my phone number and greet me by name. So here they're asking me how they can help me. So I'm going to say I want to file a claim. This interaction is with our self-service chatbot using Amazon Lex. And through this, they're asking me, hey, what is the location of the accident? So I can say, for example, street. Yeah, and again, through customer profiles, they're able to know which I have multiple cars on my account. So I'm going to tell them it's my Toyota. And finally, they are asking me to upload some documents via a URL that they'll send through. and they're asking, hey, do I want to send that through chat or email? I'm just going to text or email, so I'm just going to say text. Cool. So you can see that I got a +1 here, a notification to upload the text, but I won't demo that in here. What else I want to demo is escalation to agent. So in this example, maybe this is the first time I'm filing a claim, and I would like to just double check with an agent. So just want to say talk to an agent. Then I get the option for phone call chat, and since we're demoing this two-way SMS capability through chat, so I'll select chat. Finally, they say, let me find you the right adjuster. So now on the right-hand side, I have my contact control panel, which is the soft phone for Amazon Connect, and I'm logged in as Quinn the agent. If I go available now, I should have a chat come in through my interaction with the customer. And here we see all the interaction history between the customer and the chatbot, and the agent is able to quickly get an idea of what the context of the conversation is. Now the agent is able to reply and say, hey there, how can I help you? And we can see that this message is able to be delivered through to the SMS side. So when do I and the customer and agent is able to have this back and forth conversation. At the end of the conversation, the agent is able to ask if the customer, if they have, if there's anything else that that the agent can help with. If not, the agent can end the chat. And once the chat is ended, the agent can go back to available and help other customers. But in addition to that, our solution supports asynchronous chat out of the box. So if the customer was not able to resolve the issue or they want to come back within a day, they could say, hey, I have another question. Then the customer is able to be put back into the queue, and the chat would be routed back into the queue. And you're able to use Amazon Connect to do a dip and route them to the agent that helped them last, if the agent's available, and do some other routing logic there. But in this demo, I just wanted to show that the asynchronous chat is here, so that all the context from the previous chat is also maintained, so that the next agent is able to get context to help if the customer had came back from this conversation. So this is the demo for this two-way SMS. Next, Mike is going to do a code walkthrough of the framework to show you how it actually works.
Awesome. Thanks, Quinn. Right now I've transitioned to Visual Studio Code, in which I have just pulled down our GitHub repository. I'm going to be walking through it a little bit. The first area that we're going to be focusing on here is the SRC folder. And this is what's going to hold the majority of our logic, which is going to be within Lambda functions. So in the source folder, we have a folder called Lambda, and this is where all three of our Lambda functions are going to reside, and all the code that corresponds with those Lambda functions. The first two, or the last two, the inbound and the outbound message handler, we've talked through before during our architecture review. But the digital health check is one that we didn't quite cover on that, so I'll just cover it very quickly here. The digital health check is for the digital channels, as the name might suggest, to do health checks on our service and ensure that our endpoints are standing up properly and can receive messages. So this is something that gets hit from some of the digital channels that you may integrate with on occasion. For example, the one that we've built this digital channel health check for is Facebook. So going live, this framework is going to have connectors into SMS channels and then into the Facebook channel. SMS obviously does not have a health check, but Facebook does require that. And we expect other digital channels to require a similar pattern as well. So that's what this Lambda function is. I'm not going to dive too deep into that integration point, but we'll focus instead on the inbound and outbound message handlers. So if we expand this a little bit, all three of our Lambda functions actually follow the exact same pattern. So in the root folder here, we'll have an index.js, and this is where the Lambda code starts getting executed. So when we come into the handler here, what we want to do as part of this index file is we want to identify what channel this is meant for and allow for a specific channel-specific handler to parse the payload from that respective channel and can make the conversion from that respective channel's format for the API payload or the SNS payload in the example of the SMS use case. Sorry, that was a mouthful there. Into what we need to communicate with Amazon Connect. So within our handlers folder here, we actually have individual handlers for each of the channels that we are integrating with. So if we click on this SMS channel, this is going to be responsible for taking the payload from SNS, which includes our SMS, and converting it and calling the Amazon Connect API in the form of our inbound helper. So the channel handlers are responsible for the translation of from the channel to Amazon Connect, and then the inbound helper class is responsible for the actual integration to Amazon Connect from our channels. So within this handler, we are parsing out the message from the payload. We are using the inbound helper to either get or create a participant. So for new chats, this will be creating our new chat contact. It will be creating a new participant. It will be storing that in DynamoDB, and then it will be returning the participant to us. For an existing chat, very similar, but we do the database lookup before all of that. So if we have an existing participant, we get that from the database and we return it here. The two things that we're passing in, like I mentioned in the architecture, is the channel type. So channel type is just a SMS or Facebook or whatever that channel type is, whatever you prefer to name your channels. And then the get vendor ID is calling the method below here to get that unique identifier that's specific to the channel. So in this case, it is the SMS origination number. So that's going to be my phone number. So once we have that participant, then we're able to send our message. So for SMS, it's very easy. We just simply send the message body from our text message to Amazon Connect. And that's how easy it is to build one of these integrations. If we take a look at the inbound helper logic very quickly, we can see the public methods here, the module exports. So we support get or create participant, we support sending message, and we also support sending acknowledged event and sending a typing event. So for text messaging, we obviously can't determine when the customer is typing to you. But for our digitally native channels, there might be channels with integration to have that type of event and send that through. Similar to acknowledge, so acknowledge is kind of like a read event of, yes, the customer has read this. We don't have that with SMS either, which is why it's not being invoked within our SMS handler. And that's our inbound message handler Lambda function. So if I were to go and create another channel and extend this framework, I would add another handler here. I would modify the logic within index to account for the channel-specific API path, and then I'd be on my way. We could use the same logic within the inbound helper, and we make this very easy and extensible. Within the outbound message handler, we also have an index.js, and this file, again, is going to be used to identify what channel handler we need to hand this payload off to fulfill the message being sent to the expected recipient. So within the index, we're actually going to reach back out to our DynamoDB table. We're going to find the vendor ID in the channel, and then we're going to pass that vendor ID off to the applicable channel handler. So there's a Facebook and an SMS channel handler, just as we saw in the inbound. And these channel handlers are actually going to be used to send the message. So if we take a look at our SMS, this is simply getting a phone number and the message from our index and sending our message via our Pinpoint API. So we're using the AWS SDK to communicate with our AWS Pinpoint service and send that message to the expected recipient. Similarly with Facebook, instead of using our Pinpoint service, we would just be calling the Facebook APIs directly and coordinating that API conversation within the Facebook channel handler. Just quickly backing up then, the one last thing I wanted to talk to through code here is going to be within our lib folder. And in our lib folder here at the root level is going to be where we define our CDK stack. So this is where we're actually defining the resources that will be deployed, in which Quinn is going to demo here shortly. But this is where we're actually creating our Dynamo database table, where we're creating our SNS topics, where we're creating our Lambda functions. All of this will be defined and can be modified to extend in this TypeScript file here. And that'll wrap up our code review here. I'll hand it back over to Quinn then to talk through or walk us through a actual setting up a deployment of this stack. Quinn?
Thanks, Mike. So I'm now going to walk us through how to deploy this solution for the SMS use case. One of the prerequisites to the SMS use case is to actually obtain a phone number from Amazon Pinpoint to enable the two-way communication channel. The first step is to go to the Amazon Pinpoint console, select the region that you would like to be in, click Create Project, give your project a name, and click Create. Once you've created the project, go ahead and configure the SMS channel. So first we want to enable SMS channel for this project. We want to select our default message type to transactional. Out of the box, the default limit for the Pinpoint spending is $1 USD. Please check out the documentation on how to get that increased. And finally, we need to go to this advanced configuration to actually request a phone number. So based on the region that you're in, there are different countries that are supported for two-way SMS specifically, as well as SMS. So since we want to do the demo for United States, we'll select a toll-free number for support. We'll enable just the SMS channel, and we'll select the transactional message as the default. Then we'll go next and request this phone number. Once we have the phone number and the Pinpoint project created, we need to go ahead and get a couple of details. So the first thing is to get the phone number we just created. So it would be this one. Make sure that we get the country code as well. Let's paste that somewhere safe. Then we need to get the Pinpoint project details. So what we need is the project ID for Pinpoint. So we need to get the project ID for the Pinpoint. And now we can go through the deployment steps. Now that I've loaded up the Visual Studio Code containing the code for this project, we first have a few other prerequisites that we have to do. The first one is we need to make sure that we have the AWS CLI installed with the right profile with the IAM credentials. So if you have to do that, please refer to the documentation to set up your AWS CLI. Once you've set that up, we'll need to install the AWS CDK. The CDK is the cloud development kit provided by Amazon to AWS to help programmatically create these resources for inside your AWS environment. I'll quickly walk us through how to do that. So one of the dependencies for AWS CDK is TypeScript. So the first thing to do is install TypeScript. And once we have TypeScript installed, we want to go ahead and install the AWS CDK. So Once we have AWS CDK installed, if this is the first time running CDK in your account, you'll need to run the CDK bootstrap command. Before we do that, we have to provide it with the AWS account ID and the AWS region we would like to run the CDK bootstrap in. So in order to get the account ID, we can use the STS get caller identity command to get our account ID with the credentials that we're using locally. Then we supply the AWS region by exporting it as an environment variable. And finally, we can run the CDK bootstrap command, passing in the credentials that we need to do locally. And as you can see, I've already bootstrapped in my environment, so it's telling me everything is good to go. Now let's move to installing and deploying our framework. So the first thing to do is to clone this repository from GitHub. Once you've done that, from the root of the directory, we can run npm install to install all the dependencies for this project. Once the npm, all the npm packages are installed, we will then need to traverse and go into the Lambda function directories to install the npm install for those functions as well. Because when we do the deployment, it's going to deploy what we have installed locally. It's going to package up the Lambda functions and deploy it locally. We also have a deploy script that we have written in the GitHub repository that you can deploy by just executing the deploy script and providing variables. But for the purposes of this demo now, we will go through the step-by-step process of getting this deployed. Now that we have the CDK project installed, we can now CD into our Lambda inbound handler to do our install. So let's do npm install. And once this is installed, let's move to the second Lambda function, which is the outbound Lambda to do the install. And since today's demo is for SMS, we won't be installing the digital channel health check, as that won't get deployed, as it's only getting deployed with the Facebook demo channel. So now in the outbound message handler, we also do our npm install. And once everything is installed, we will CD back to the root and run CDK deploy. CDK deploy will deploy this entire CDK project by packaging up all the resources required and deploying it through CloudFormation. Now it's the time to get the pinpoint project IDs that we had from earlier and make sure to use them in our CDK deploy command. So command that I'm going to execute is CDK deploy with the local CLI profile, as well as providing the context that is required for the different variables. So in this case, we're passing in our Amazon Connect ARN for the Amazon Connect instance we're using. We're passing in a contact flow ID, which is the contact flow ID we would like this to be executed when the chat comes in. We pass in a SMS number, which is the phone number we just claimed from the Amazon Pinpoint console, as well as the Pinpoint project ID. To deploy the Facebook channel reference architecture, there are different context variables that you need to pass in. Please refer to our GitHub README for more details. But as soon as we have this done, we can run the CDK deploy command, and it will compile everything that we need locally and create a CloudFormation template and ask us if we wish to deploy. Once you click yes, this will go through the deployment process. Perfect. Now that our stack has deployed, we can go to the Pinpoint console and finish the configuration. So once we come to the Pinpoint console, we go back to the project that we selected. We can choose the phone number that we claimed. And then we can go down into the two-way SMS, enable two-way SMS, and select an existing channel. So we want to select the inbound SMS topic that was deployed through the CDK. And then we click save. And now if we go ahead and text this number, it will trigger the contact flow and be able to have the two-way communication with the Amazon Connect chat. Awesome, that concludes the deployment of this project. For any further details and other guidance, please refer to the GitHub repository, as well as the blog post that we are releasing together with this new functionality. Thank you so much for your time, and have a good day.